Hey, Math Journey! Today, I've got a mind-bending puzzle for you. Imagine this. You're given just one single point on a cubic polynomial, just one. And from that, you're supposed to figure out all four coefficients and predict the function's value at another point. Sounds impossible? Stick around to see the magic. Alright, here's what we know. We have a function f of x equal to a times x cubed, plus b times x squared, plus c times x, plus d, where a, b, c, and d are rational numbers. The only thing we know is that f of square root of 2 plus square root of 3 equals square root of 2. What's interesting here is that we don't know anything else about the coefficients, just this one piece of information. And the question is, if we know this, can we figure out f of 10? Before we tackle this together, take a moment to think about it. I'll give you a few seconds to ponder and come up with your solution. To make any sense of this, let's break it down. We're told that x is equal to square root of 2 plus square root of 3. So let's calculate x squared and x cubed, because our function involves terms like x squared and x cubed. Let's start with x squared. X squared equals square root of 2 plus square root of 3 squared. Expanding this, we get 2 plus 2 times square root of 6 plus 3, which simplifies to 5 plus 2 times square root of 6. Now we will continue with x cubed. Expanding, square root of 2 plus square root of 3, cubed gives us 2 times square root of 2 plus 6 times square root of 3 plus 9 times square root of 2 plus 3 times square root of 3. Combining terms, we get 11 times square root of 2 plus 9 times square root of 3. So, now we have expressions for x, x squared, and x cubed. Let's plug these into our function. Now, we know that f of x equals square root of 2, when x is square root of 2 plus square root of 3. Expanding f of x as a times x cubed, plus b times x squared, plus c times x, plus d, using the values of x, x squared, and x cubed we just calculated, we get f of square root of 2 plus square root of 3 equals a times 11 times square root of 2 plus 9 times square root of 3, plus b times 5 plus 2 times square root of 6, plus c times square root of 2 plus square root of 3, plus d. Since we're told this equals square root of 2, we'll group like terms to set up equations based on the coefficients of square root of 2, square root of 3, and square root of 6. Here's where things get interesting. Since a, b, c, and d are rational, each term with a square root has to independently equal 0, since irrational terms must balance out separately. This gives us four equations. 1, 11 times a, plus c, minus 1 equals 0. 2, 9 times a, plus c, equals 0. 3, 2 times b equals 0. 4, minus 5 times b, minus d, equals 0. From these we find. From equation 3, b equals 0. Plugging b equals 0 into equation 4, we get d equals 0. From equation 2, we get c equals minus 9 times a. Using this in equation 1, we solve for a, which equals 1/2, and c equals minus 9/2. So our function becomes f of x equals 1/2 times x cubed minus 9/2 times x, which we can also write as x cubed minus 9 times x, divided by 2. Now, all that's left is to plug in x equals 10. F of 10 equals 10 cubed minus 9 times 10, divided by 2, which simplifies to 1000 minus 90, divided by 2, which equals 910 divided by 2, and that gives us 455. So, the answer to f of 10 is 455. And there you have it. With just one piece of information, we uncovered all the coefficients. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.